Hi, my name is Chris Birchfield. I'm with Global Fireproof Solutions. Today I'm here as a third-party representative to basically do an inspection and application of the DC315. What we specialize in is applications and training and education of these types of NMS and coatings to be able to show how well they apply, how they meet certain mills for fire ratings and so forth. And what we're going to do today is basically show the difference of how the product can go through various rigs, and from our standpoint we're going to be able to do the application and test the mills on it as well. My position here is to do the application as well as witness it. My certifications are 10 years in doing application as well as being an ICC certified applicator and inspector. Alright, what we're going to do next before we actually do the application, and when you're working with foam, of course, you have a very bumpy surface. In order for an applicator to do an accurate spray film thickness, he needs a flat surface. So what we're going to install here is a couple of metal plates that we're going to use as basically our tags, that as we're coating this foam, we'll put the same mills basically across the tags. So we'll be able to do a wet mill thickness to see where we are in our application.
Where'd you get those plates?
You can get these plates commonly anywhere, like a Lowe's, Home Depot, hardware store, and we prefer to use the metal plates. And the reason we use the metal plates is because there's two things that we can do to it. One, of course, you got a nice smooth surface to work with, so when the coating goes on, it's going to be the same as what you're putting here. The second thing is, once it dries, you can actually do a dry film thickness with an electronic meter. So you can actually regulate that as well. So if an inspector comes back later on and wants to see the mill thickness, you can put an electronic meter on it and check it out as well. So very advantageous to have this tags on here when you're doing large jobs, because you want to periodically test out your mill thickness throughout the jobs. The other thing is that you can take a Sharpie and mark on the back of it the information about the project, how many mills, and so forth. That way it's also documented from that perspective. So you can give an inspector this tag along with your documentation so that he can review it for himself. Okay, we're going to space a couple of these out. So in this instance here, just taking a simple nail, basically, and we're using this to just stick it in, flush it up.
Now, on a normal job, you might use one every 100 feet or so.
Correct. Yeah,
Even a couple hundred.
You don't need to put these all over the place, because right now we're just going to show, basically, when you're doing an application, you want to be consistent in your whole application. The next thing we'll do is, when we're doing the application, you're going to have a setup. It's going to vary in your application. You may use longer wands. Right now, for this particular application, we're going to use a shorter wand, because if you just have the gun, you're not going to be able to reach, and you're going to be stretching. Whenever you're spraying, if you're stretching, you're actually not going to get a consistent mill. So you got to think of yourself kind of as a robot in the sense that you want to be consistent in your distance away from the application. So when you're spraying, you want to keep the same distance up and down. A lot of guys that are spraying, a lot of times they're going to reach for things, and when they reach for things, you're not going to get the consistency of the mills. Hence, where your tags are a lot of times helps decipher that as well. So whenever you're setting up the spray, basically, you can use various length of wands on your guns to get the reach you need. You want to make sure you have adequate reach, because you want to make sure your mill thickness is consistent. Now, the spray pattern we choose for these types of installations, when you're spraying foam, foam's going to be various. Okay, it's going to be, some of it's going to be really bumpy, lumpy, some of it's going to be very tight and smooth. But in order to get a consistent application on this, we're going to do a one-coat process, what we call crisscross. A lot of guys call cross-out. What basically that means is you're going to spray vertically, up and down, and then come back and cross it out horizontally. What that will make sure that you do is that you're catching every angle of all the bumpy surface, whether it's up or down or sideways. One of the advantages of doing that. If somebody comes in and just sprays this out, they may not be able to get this, and what will happen when an inspector walks in, he's going to see what they call holidays, which are light spots. And those light spots is what you don't want, because you're not going to have your consistency. So crossing out foam application is very important. Basically, in your standard applications, you're going to adjust accordingly to the surfaces that you're working on. Now, in this application here, we're looking at getting a mill thickness of about 12 mils dry, which is 18 mils wet. You have basically the average around 66% solids, I believe.
Yes.
So when it dries down, you want to make sure you get a good, consistent mill thickness on that. Now the tip we're going to use on this one is a 519, pretty much standard. The 5 stands for the width of the fan, which actually is double. It's 10 inches. So when you get a 5 series or a 4 series or a 3 series, you double that. That's going to be your fan width. okay? The second part is your orifice size. The larger the number, of course, the larger the hole on it. Now, you got to be careful about going up in your orifice. So right now we have a 519. We may jump to a 521, may jump to a 525. Now, the difference is that means you're going to be putting a lot more product on the wall. Now, that might not be necessary. Now, application-wise, an advanced spray guy can use a larger tip, like a 521, 525 on up, but he's going to have to be faster with his application, okay? So he's got to compensate that. What we're looking for is consistency of being able to do a standard application, not having to fly through it, but using about a 519 tip will get you to the 18 mils wet that you're looking for.
In one coat.
In one coat.
And that's using the Titan Advantage 400?
Yes, and based on this of what we're talking about on a lot of these rigs we're working with, the reason we're using different rigs is to be able to show that in certain jobs you can use a smaller rig to be able to do the same mill thickness. You don't necessarily need a big rig to push the product. So what we're showing today and demonstrating is that I can use one of the smallest rigs here to actually spray the product. Now the difference is you don't want to use a small rig on a large product because you'll wear out the rig. So what we're showing today is typically be able to use a small rig to be able to push the product through to meet the mills that you need to meet.
And this is of the DC 315 coating that was after mixing 19,300 viscosity.
That's correct.
Thank you.
All right.
Let's do it.
All right, so what we're going to do here is I'm going to do a sample fan. Now, whenever you're spraying, you always want to do a sample fan because you want to make sure which way your tip is turned. So at this time, basically, just do a quick fan. And you see right now, what we have is we're going to have a horizontal and vertical we'll set up here, but we're going to go ahead and do the vertical first with this spray pattern. Then I'm going to spin the tip around, and then we'll do it horizontally.
Okay, so we start the clock, begin right once you start to spray. And we're doing that so we can show the time needed to help assist you in labor charge.
All right.
Ready? Let's go.
You want to make sure you overlap your scope. Now we're going to come back and we're going to cross it out. Start at the bottom of the pot, doesn't matter.
All right, stop the clock at 1 minute and 1 minute 14 seconds.